The steel rod count is accurate. We can move this pallet.
Cross-referencing the superalloy batch numbers now, everything appears correct.
こちらは問題ありませんね。はい、記録しておきますね。
The ultrasonic reading on sample 12 is complete.
Cross-reference that with the X-ray diffraction data immediately.
The induction furnaces operate at extreme temperatures, requiring constant monitoring as alloying elements are introduced.
Maintain pour rate at 50. The temperature is stable.
Confirmed. Trajectory is holding steady on mold 4.
The flow rate on sector 4 is fluctuating again.
It's still within tolerance, but keep an eye on the temperature curve.
Sensors line the walls, ensuring precise temperature regulation as the metal cools slowly on the conveyor racks.
Check the thermal gradient on rack 4.
Stable at 850, the cooling rate is optimal.
Press descending, maintain visual on the billet. Confirmed, pressure steady. We have heavy spark scatter on the east side.
The plasma spray process applies a dense ceramic layer, crucial for protecting the superalloy blades in high-temperature environments.
Door opening now. Confirm all clear.
Confirmed, all clear. Moving to data log.
Heat levels steady at 1200.
Acknowledged. Advancing the next batch now.
The probe detected a microfracture at C4.
Confirmed on the X-ray. It's failing tolerance.
The ultrasonic reading here shows a subsurface anomaly at layer 3.
Confirmed. The X-ray data correlates with a minor density variation.
Temperatures are stable across all zones.
Confirmed. We are ready for the pressure ramp.
Main seal engaged. How are the hydraulics looking?
Pressure steady at 50 psi. We are clear for the cycle start.
The oscillation reading on sector 4 is slightly high. Yes, but the surface finish is still within tolerance.
Alignment check on stage 4.
Reading green. Secure the clamp. Alignment is good on stage 3. Laser confirms position.
Torque it down. Setting P2 confirmed.
Check the thermal gradient on zone 4.
Ramping up stabilization now.
Easy now, just a few more inches. Hold it there.
Looks good, set it down. We have alignment on the starboard side.
Confirmed. Engaging torque sequence now.
Laser alignment is green. Tolerances are nominal.
Acknowledged. Initiating final torque sequence.
Lowering to commence. All personnel verify clearance.
We have positive aligned guides.
Alignment confirmed on sectors 4 through 7.
Roger that. Proceed with final seating.
Pressure is stable at 10,000 psi, approaching the red line.
Confirmed. The integrity holds. We can proceed with the next sequence.
We've reached maximum pressure, all systems nominal.
Excellent. The data logs confirm stabilization.
We are clear for the next phase of acceleration.
Readings are stable.
Holding at max velocity.
We have a consistent spike around the lower range.
Noted. Let's cross-reference with the thermal data.
The vibration on the starboard sensor is exceeding tolerance at 4,000 RPM.
I see it. Logging the anomaly now. We should reduce power.
Check the pressure on manifold 3. It's fluctuating.
I see it. Adjusting the flow rate now.
We are holding at 20% thrust. All systems appear nominal at this phase.
Pressure is spiking on injector 2.
Acknowledged. Adjusting the flow rate now.
Thrust vector looks good.
Confirmed. We are green across the board.
Look at the stress levels here on the readout. It's slightly above the threshold.
Yes, I see that. Let's double check this port manually.
Port 7 shows minor heat stress.
Confirmed. Logging the aberration now.
Go ahead and torque that down.
Got it. Specified range achieved.
This data confirms the stress tests passed.
Excellent. Let's sign off on the certification.
Torque wrench secure on mount 4.
Confirmed. Ready for tensioning.
In this massive high bay facility, precision is everything. Forklifts navigate the wide aisles, securing the completed jet engines.
We need to reroute the Atlantic corridor now.
Done. The system synchronized the new path. ETA remains unchanged.
Excellent work. Keep monitoring the weather grid. Conflict on the Eastern European route, rerouting now.
The Atlantic corridor is clear. Push the convoy through.
Synchronization complete.
Confirmed.
All right, bring it down slowly. Watch the clearance on the starboard side.
Easy now.
Bring it down another 2 feet. Easy now.
Copy that. Looks aligned.
All right, it's secure. Get the chains on.
These massive jet engines represent years of engineering, now entrusted to the heavy haul convoy.
Keep it steady, slow down just a little bit. Roger that. It's almost aligned with the pylon.
Easy now. Bring it left just a few inches. Hold it there.
Torque set to 7 to 5.
Confirmed. Reading matches the schematic.
Alignment check. Station 4.
Reading green. Proceed slowly.
Clear on the left side, Cap.
Roger that. Bring it up 2 inches.
Watch the clearance on the pylon. Final torque check on this coupling.
Confirmed. The readings are stable. Harness 7 is secured and tagged.
Engine pre-start sequence engaged. All personnel confirm green status.
Confirmed green. Moving to safe zone.
Gauge pressure holding steady at 25 psi.
Confirmed. Checklist item 4 complete. Clear to power up.
Telemetry looks stable. Increase thrust to 60%.
Confirmed. 60% and holding.
All parameters are within tolerance. We are good to sign off.
Agreed. Final inspection complete.
All parameters are within tolerance. Borescope clear?
Confirmed. The turbine blades look good. Ready for sign-off.
Finalizing the report now.
Bathed in the golden light of dawn, the new aircraft stands ready, a testament to precision engineering.
From this vantage, the scale of global industry is breathtaking.